Hello and welcome to today's lesson. We're going to be looking at the surface area of cylinders, or tin cans, if you like to think of them that way. I've drawn one here, and the important dimensions that define any cylinder are the height and the radius. And the formula for surface area is as follows. There's a circle on the top. Okay, so a circle's area is pi r squared. There's a circle on the bottom. So that means there's two circles, so 2 times pi r squared, plus what we call the lateral area, the side here. Now, how we get the side is actually kind of interesting. If you think of it as a rolled up piece of paper. So say I cut it down this side here and I unroll it. Then I get this longer rectangular shape. And it's got the same height as the original cylinder. Okay, so just picture this side here going out like this, and this side unrolling to there. So we got this rectangular shape. And the dimension of the top of our rectangle is the same as this distance here, which is the circumference of the top circle. And the circumference of a circle is 2 times pi times radius. Now, if you wanted the area of this rectangle, it would be the base of the rectangle times its height. So this gives us what is actually the lateral area of the cylinder. And that gives us, with the two circles on the top and bottom, our total surface area formula. So that is how we work with cylinders. So I'm going to clear the screen and I'm going to do an example with some numbers in it. Okay, so let's see what we can do here. Let's produce a cylinder. So let's say there's a cylinder. Somebody comes along and says the height is 10 centimeters and the radius is 6 centimeters, and this is a can with no lid. And somebody asks how much tin was used in this can. How much tin? Well, that means I'm going to take my formula and I'm going to tweak it a little bit. I only want one circle on the bottom. I don't want this circle on the top because there's no lid. So I only want one circle. And then, of course, I do want this lateral part because there is tin there. So that's 2 pi r h. So I've tweaked my formula, and now all I got to do is put in the radius and the height and throw it into my calculator. So my radius is 6 and the height is 10. So let me just show you something before I put it through on the calculator. What you can do is square the number. 6 squared is 36, and then leave it as 36 pi. And then over here, 10 times 6 times 2, which is 120 times pi. So one way that you can leave your answer, these are of course like terms, so I can combine them and call it 156 pi square centimeters. Or if you prefer, you can throw it all through on your calculator, and you should get 490.09 square centimeters. And there you have it. That's about all there is to dealing with cylinders. So I think I'm going to stop there, and we'll catch you later.